We now discuss the solution of a problem from the section Sequences and Series. The problem is related to the arithmetic progression. This question has appeared in the joint entrance examination main held on 28th June 2022 in the first shift. The given question is, let A be a set consisting of 1, A1, A2, etc. A18 and 77 be a set of integers with 1 less than, A1 less than, A2 less than, etc. A18 less than 77. Let the set A plus capital A is equal to the set of all x plus y, xy belongs to A, contain exactly 39 elements. Then the value of A1 plus A2 plus etc. A18 is equal to. We are given a set of integers capital A consisting of 1, A1, A2, etc. A18, 77. Further, these integers in A are in ascending order. So 1 less than A1, less than A2, less than etc. less than A18, less than 77. It is given that the set capital A plus capital A defined as x plus y, where x belongs to A, y belongs to A, contain exactly 39 elements required to find the value of A1 plus A2 plus etc. plus A18. We now discuss the solution of the problem in detail. We are given the set of integers capital A is the set consisting of 1, A1, A2, etc. A18, 77. Further, these integers are in ascending order, that is 1 less than, A1 less than, A2 less than, etc. less than A18 less than 77. Given the set capital A plus capital A is equal to x plus y, where x belongs to A, y belongs to A, contain exactly 39 elements. Agreed. Now, we have 1 less than, A1 less than, A2 less than, etc. less than A18 less than 77. To each integer, add 1 throughout. That is 1 plus 1, certainly less than 1 plus A1, less than 1 plus A2, less than etc. less than 1 plus A18, less than 1 plus 77. Agreed. Because there is this less than inequality is there, and we are adding 1 throughout, so the less than will maintain, and these are the elements of A plus A. These are the elements of A plus A. They are 20 in number, and these are distinct because each element is less than the next one, is less than the next one, so on and so forth. Therefore, these are 20 distinct elements of A plus A. Agreed. Now, to 77, add A1, A2, and so on and so forth. So, A1 less than 77, less than A2 plus 77, less than etc. less than A18 plus 77 is less than 77 plus 77. So, that means to A1, A2, A18 is and 77, we have added 77 throughout, and the inequality is maintained, and these are the elements of A plus A, they are 19 in number and these are distinct. And no element of these is an element of the earlier 20 elements. So they are all distinct. So 20 distinct elements of A plus A, 19 distinct elements of A plus A. Thus we got 39 distinct elements of A plus A. So that means in the question what we are talking about, A plus A contain exactly 39 elements. That means these are the 39 elements. And now the question is, what about the remaining elements? X plus Y, X belongs to A, Y belongs to A. There will be other elements of A plus A. What happens? So the remaining elements will be one of these 30. So if you take an element in the remaining numbers, then that will be one of them. So these are the 39 distinct elements of A plus A, and the remaining elements of A plus A belong to this above set of 39 elements. Agreed? So if you take any other element other than this 39, that will be in A plus A, that will belong to these above 39 elements. So that means the other elements will be repeated and repeated from these 39 only. Agreed. Now, our goal is to show that A1, A2, A18, 77, they are in arithmetic progression. For that, 1 plus 1, we have 1 plus 1 less than 1 plus A1 less than 1 plus A2 less than 1 plus A3 less than 1 plus A17 less than 1 plus A18 less than 1 plus 77. Agreed. And we now consider the elements A1 plus Y, where Y belongs to A. That means the first element is fixed A1 and Y is varying over A. So you will get again 20 elements. What are they? A1 plus 1, A1 plus A1, A1 plus A2, A1 plus A3, so on and so forth. So A1 plus 1 less than A1 plus A1, A1 plus less than A1 plus A2 less than A1 plus A3 less than A1 plus A17 less than A1 plus A18 less than A1 plus 77. Because they are all distinct. They are all distinct. So, but we have already told you that the remaining elements will be one of these 39 elements. So therefore, who are these fellows? These fellows are none other than the elements of those 39 elements. Now let's look at this one. A1 plus 1 is not 1 plus 1. Why? Because 1 plus 1 less than 1 plus A1. So A1 plus 1 is equal to 1 plus A1 because commutative law holds good among integers. Agreed. Now A1 plus 1 less than A1 plus A2, A1 plus A1, A1 plus 1 less than A1 plus A1, 1 plus A1 less than 1 plus A2, and I told you that the remaining elements will be one among those 39 elements only. So these are the 20 elements of those 39 elements. So A1 plus A1 must be equal to 1 plus A2. Right, because less than, and we have told you the remaining elements are none other than these 39 elements only. Now this will imply 2A1 is equal to 1 plus A2. 1 plus A2. That means A1 is the arithmetic mean of 1 plus A2. So that means 1 A1 A2 are in AP. This means the common difference is A1 minus 1, first term minus the second term minus first term, is equal to A2 minus A1. Agreed. Now let's get into the next one, the the pink one. A1 plus A2 must be equal to 1 plus A3. Must be equal to 1 plus A3. So this will imply A3 is equal to A2 plus A1 minus 1. But A1 minus 1 is D. So this is A2 plus D. So A2 plus D. That means by adding D to A2, we are getting the next term. Next, etc. Continue like this. A1 plus 17 is equal to 1 plus A18. So you take this element, so that will be equal, that will imply A18 is equal to A17 plus A1 minus 1. But A1 minus 1 is D. So A18 is equal to A17 plus D. By adding D to A17, you are getting A18. Next, A1 plus A18. So A1 plus A18 is 1 plus 77. 1 plus 77. This means 77 is equal to A18 plus A1 minus 1. That means to A18 add D, then you will get the 20th term, that is 77. So what does it say? All this tells you that 1, A1, A2, etc., A18, etc., 77 are in arithmetic progression. Now the problem has become easy. Now required to find the value of A1 plus A2 plus A18. That we will do in the next slide. We have this 1, A1, A2, etc., A18, 77. They are the 20 numbers. They are in AP. Agreed. And if I add all these terms, that means the sum of the first 20 terms, 1 plus A1 plus A2 plus A18 plus 77 is S20. And I will use a formula. Sum of the first n terms of an AP denoted by Sn is equal to n by 2 into, in brackets, A plus L, where L is the last term and A is the first term. So we'll use now n is 20 and A, the first term, is 1 and the last term is 77. So that will be equal to 20 by 2 into 1 plus 77. That is 77 plus 1 is 78. 20 by 2 is 10. 10, 78s are 780. Now 1 and 77 are known. That is 1 plus 77, 78. And this A1 plus A2 plus etc. A18 will be 780 minus 1 plus 77, that is 78. That is 702. That's what is wanted in the question. So A1 plus A2 plus etc. A18 is 702. So the answer to this question is a numerical type, is 702. 702. The answer to this question is 702, and that is the detailed discussion of the solution of the problem from the section, sequence and series, and the problem is related to arithmetic progressions. And I am sure that you have understood the solution of this problem, and I wish you all the best. Thank you.